Unit 10, Lesson 3, Calculating Atoms. Avogadro's number is what we use to convert between moles and atoms. And so we know that the number of atoms in 12 grams of carbon is the same as saying that there is 6.02 times 10 to the 23 atoms in a mole of carbon. So first thing we need to do when we need to convert from moles to atoms is we need to write down the unit that we're asked for, then we write down the given value, then we apply the unit factors to convert the given units to the desired units. So for example, how many sodium atoms are in 0.12 moles of sodium? Well, we want atoms of sodium, and we have 0.12 moles of sodium. And we know the conversion factor between moles and atoms is 6.02 times 10 to the 23rd. So we start with what we have, which is 0.12 moles. We use our conversion factor of 6.02 times 10 to the 23rd atoms for every 1 mole. Moles cancel, and we're left with atoms of sodium. So now, how many zinc atoms are in 4.25 moles of zinc? Well, we want atoms of zinc. We have 4.25 moles of zinc, and we know that for every 1 mole of zinc, there's 6.02 times 10 to the 23 atoms of zinc. So we start with 4.25 moles. We use our conversion factor of 6.02 times 10 to the 23 atoms for every 1 mole. Moles cancel, and we're left with atoms of zinc. So, one more time, how many titanium atoms are in 11.5 moles of titanium? Well, we want atoms of titanium. We have 11.5 moles of titanium, and we know that 1 mole of titanium is 6.02 times 10 to the 23 atoms. So, we start with 11.5 moles of titanium. We use our conversion factor of 6.02 times 10 to the 23 atoms per mole. Moles cancel, and I'm left with atoms of titanium. So we're multiplying 11.5 times 6.02 times 10 to the 23rd divided by 1. So carbon atoms. We want to know how many atoms of carbon there are. We know we have 0.23 moles of carbon, and we know that 1 mole of carbon is 6.02 times 10 to the 23 atoms of carbon. So we take 0.23 moles of carbon, multiply by 6.02 times 10 to the 23 atoms divided by 1 mole. Moles cancel, and we get 1.34 times 10 to the 23 atoms of carbon. So now it's time for you to check your understanding. Now, what if we want to convert from atoms to moles? Well, we do the exact same thing. So how many moles of potassium are in 1.25 times 10 to the 21 atoms of potassium? Well, we know we want moles of potassium. We have 1.25 times 10 to the 23 atoms of potassium, and we know that for every 1 mole of potassium, we have 6.02 times 10 to the 23 atoms. So we start with what we have, which is 1.25 times 10 to the 21 atoms. We use our conversion factor, and we've now placed the atoms in the denominator so that atom will cancel. And if we take 1.25 times 10 to the 21 times 1 divided by 6.02 times 10 to the 23, and we get 2.08 times 10 to the negative 3 moles of potassium. So how many moles of aluminum are in 5.75 times 10 to the 24 atoms of aluminum? Well, we want moles of aluminum. We have 5.75 times 10 to the 24 atoms of aluminum, and we know that for every 1 mole of aluminum, we have 6.02 times 10 to the 23 atoms of aluminum. So we start with what we're given, 5.75 times 10 to the 24 atoms, times our conversion factor, which is 1 mole over top of 6.02 times 10 to the 23. Atoms cancel, and we're now left with 9.55 moles of aluminum. So how many moles are in 3.96 times 10 to the 24 atoms of barium? Well, we want moles of barium. We have 3.96 times 10 to the 24 atoms of barium, and we know our conversion factor. So we start with what we know, 3.96 times 10 to the 24 atoms of barium times our conversion factor. We will put atoms in the denominator, so atoms cancel, and we are left with 6.58 moles of barium. So last one, xenon, and we know we have 1.05, and